Today we gonna cook, but not like we do in Clash Royale. No. We get chopped in Clash Royale. Today we cook, no cap, pure Sigma from every one of you. All right. So, check it out. For all polynomials that you ever give me, f of x and d of x, where we have some function where d of x is a smaller degree, just means a smaller power, less than f and it's not 0. There exists a unique polynomial, or several unique polys, that we'll call q of x and r of x, such that the following winds up true. Now, this stuff looks kind of ugly. Like, realistically, looks ugly, but oftentimes in math, a lot of stuff looks ugly and it isn't really. We're going to say this thing works out as follows. I'm going to switch colors so it's like front row. We get f of x. Now, and we're going to rearrange this a couple times, but we'll probably just talk about this. F of x, it turns out, is exactly equal to d of x times q of x. And we'll see what all these mean, and I promise that they make sense, I think. Plus r of x, just like this. Now, these pieces have names, and they work really nicely, and we'll see exactly why these names happen. What do you call the thing that we're dividing by? So the thing that's being divided is the dividend, and the thing that's doing the dividing is called the divisor. Now, we've been looking at division, right? If I wanted to divide both sides by d of x, some divisor, could I? And this is purely just a rewriting. So I'm just going to say rewriting, and just because I want to have both of them to look at. Could I divide both sides by d? So I'll do the left. It's f of x equals, or over d of x, I'm sorry. What would remain on this side? Q of x plus, you were close, Red. Or you said it all, and I keep interrupting you. I'm so sorry. Anything else we need? Everything got divided by d of x. Now, for this, these two statements right here are completely equivalent. All we've done is rearrange. They're the same meaning. Everything's identical except stuff has been moved. As we look at this, we'll just clean up and make sure that we can label some stuff. For all of this, there's a reason that we have these. F of x, and this is the only one that doesn't fit, this is our dividend, the thing that is being divided. Now it happens to be a function, all fine and dandy. The dividend. What do we call the thing that we divide by? This is my divisor. And I could have done the same thing labeling up here, but I'm okay with doing it here. What do you think q of x might represent for us? The quotient. So we have a dividend, a divisor. The answers are quotient. What's this r of x stuff that's left over? That is our remainder. And I'm not going to label it again, but just like we saw the other day when we had a remainder, you could convert it to a decimal, or you could just say it's this many out of whatever we're dividing by. This is still my divisor. I'm not going to label it again. Okay. Now, as we get through with this, we've done a couple problems here. Let's do a weird one. And we're going to see, like, just there are some weird things that happen. Everybody feel okay right here, right now, or do you have questions with anything that's on the board?
Why did we divide r of x over d of x?
So do you agree that to go, if I divide this side by d of x like this, and I wouldn't write it, if I do that to that side, I have to do it by this side? And that when we actually do that, people will mistakenly try to divide out everywhere. But remember, this gets divided by d of x, and this got divided by d of x. So in this one, it does in fact divide out, which is why we just get q, and then here's a remainder. Does that really make sense, or are you just agreeing? Okay, all right. You'd be surprised at how many times that follow-up question, does it really make sense, or are you just nodding your head? Like, if people just say, yeah, okay, the first time, when you ask that question the second time, no. Like, it happens way more frequently than you would think. All right, now, with this, we will inevitably be doing synthetic division. It's going to happen. You guys probably remember at least hearing it and talking about it. But we need this long division for a very particular reason, and we'll see why here in just a second. So here we go, a couple more examples. I'm going to call these caution. Okay. There are places where people make some really common mistakes, and we're going to see it here. And normally I try to write it as a division problem with the dividend and my divisor with the division symbol. This one I want you to actually write the way that I do. For this first one, we want to do x to the fourth minus 1 divided by x plus 1. Okay. Before you jump ahead, we're going to write this in dividend and divisor form. Like it's going to happen. It's going to look like long division. But here's the most important thing. I want you guys to help me count down real quick. 4.
3, 2, 1, 0.
Okay, you guys can count down from 4. I'm content with that. If you can do that, you can be on the lookout for what I'm about to caution you about. When we start trying to write this, first off, what is my divisor? Because that's going to be the first thing I write down anytime I'm doing these problems. So we have our x plus 1. Okay, and I'm going to go ahead and do my division symbol here. And you'll notice it's way longer than it needs to be, seemingly. But again, you guys can count down from 4, and we can write this down, and I will write it here in a minute. Are we missing any powers of x?
Yeah.
Like, again, you guys just counted down for me. We are missing a 3. We don't have an x cubed, which when I say we don't have an x cubed, I could alternatively and more correctly say we have how many x cubes? 0 of them. How many x squareds do we have in that? 0. How many x to the first powers?
0.
How many x to the 0th powers? 1. It's just a constant term. Okay. When we're missing powers, which we are here, can I just ignore them and pretend like they don't exist? No. I mean, you can, but the odds of you making it through the problem are very slim. Instead, we use placeholders. So I'm going to name this example missing powers. That's our caution. And I would say and placeholders, but I think I can identify them here. Okay. Notice I don't have an x cubed or an x squared or an x. That's okay that we don't have one, but we need to have something there so we don't lose track. How many x cubes? Could I do minus 0x cubed if you'd rather? Absolutely. Whether you add 0 or subtract 0, it doesn't make a difference. How many x squareds? 0x squared. How many x? And how many constants? Minus 1, thank you. Okay. And I'll switch back to the red for the minus 1. I'm not going to tell you completely 100% all the time. If you don't do this, you're going to get it wrong. But the odds are so much against you if you don't put these placeholders that it's easy to get goofed up. Cool. Always add the placeholders, whether it's this long division or synthetic. All right. Who's queen here? Or king? X. Basil. This is my queen. I think we can all agree. I hope we can all agree. What do you want to be able to write here? And what do you multiply this by to get that to happen? So above the x cubed, I'll write an x cubed. Okay. Matilda, I'm sorry, I feel so silly about this, but I forgot my next step. What do I do now that I've decided x cubed? Good. We distribute it. Now, I wouldn't draw these lines every time because it's going to make it really ugly when we look at it, but I can draw them and undo them on my page because I'm fancier than you. Cool. X to the 4th plus x cubed. Karina, what should I put around this? And? We subtract that whole thing off every time. If you want to distribute it, you can. You don't have to. I never do because it makes it work uglier. But now let's look. We have x to the 4th minus x to the 4th. What does it leave with? Think on. I'm not even going to write it. We have 0x cubed minus x cubed. Gives me what? Negative x cubed. And it feels super silly or so super silly. I am going to write plus 0x squared. Those placeholders help keep us straight with this. All right. Addison, who's queen now? And I need to write a what right here? A negative x cubed. What do you multiply this by to get a negative x cubed? Love it. Negative x squared. Gives me, once I distribute, a negative x cubed minus x squared. Okay. If you're going to make a mistake with stuff, whether you're distributing or not, it's probably right here, realistically. Red, can you tell me the mistake I'm concerned about you making? The distribution. When I draw my line here, I'm going to wind up with a positive x squared. The most common mistake is somebody gets a negative. Why is it a positive? Same answer. The distribution. Negative x cubed minus a negative turns to a plus. They're gone. 0x squared minus a negative x squared changes to a plus. I now get a positive x squared. Plus 0x. Casey, who's queen? And what do you multiply x by to give me an x squared right here? Another x. So here we go. X squared plus x, parentheses. Weisha, what's left? Just so it would alliterate better. X squared minus x squared, they gone. X or negative x? Good. I'm going to make it look more like that. And then last little step here, that's a negative 1. Lay, who's queen now? And what do I want to write here? So after the distribution, and let me rephrase that. I'm glad that I heard that. If you do the distribution, you're going to want to try to think to get a positive x there. I'm not. I want to write the exact same thing so that when it's subtracted, it falls out. So I think you would have given me the right answer, but what do I multiply this by to get a negative x? 1. Oh, 1 would do it?
Negative.
There it is. The negative 1 is what I'm after because I want to write the exact same thing right here. There's a negative x minus 1. Now I'll do my parentheses, and that's where it does a weird little positive thing. And what's left? 0. Okay. What is q of x? This whole top part right here is q of x. Good. Now, there's a big significance out of this that hasn't really the focus of our question. But if I wanted now to write x to the 4th minus 1 as some of its factors, you guys might know how to factor this just right off the bat. But what do we have it as factored as right now? What's one of the two factors? X plus 1 was one of them. And what's the other factor? If I asked you guys to keep factoring, how many of you feel comfortable factoring this one further? How would we possibly approach it? We're not going to right this second. 4 terms. Any thoughts? I would try grouping first, and I'm pretty sure if we factor out an x squared, it's going to be the right group. We're not going to go that far right now, but I just want to make sure that that's always on the back of our brain as we're going through these. Okay. Easy, hard, thoughts? Feels okay?
Yeah.
Now, how did you decide x was queen here? It's the first term. Here's the ephus, which I think we've spoke about before. Did we talk about an ephus in here? Okay, do you know what a curveball is?
Oh yeah,
It's
we
a,
talked about this.
okay, it's just a hard to hit pitch. Here's a curveball. I want you guys to talk this one out. I'm going to give you a head start. We will likely have to come back together. But anybody remember synthetic division exists and it's way faster and easier? So why am I being so crazy about making you do the long division? Any idea? So maybe that's a good academic answer because I want you to really understand what's happening. Realistically, we're just doing an algorithm, so I don't know that there's a ton of understanding. It's just exercises, right? Like plug and chug. Here's the reason that I do this, and it's exactly this problem. I want you guys to do the following. I'm going to write this one as dividend and divisor in nice division form. And here's what we're dividing by. Our divisor is x squared plus x minus 1. Our dividend in this problem is awful. 6x to the 4th minus x cubed minus x squared plus 9x minus 3. Now, depending on how much you guys remember about synthetic division, do you remember much about it other than it exists? So something about drop 0. Okay, it has to be a linear divisor. Everything that we've done so far up until this problem, synthetic division will work perfectly fine with. This problem, synthetic division exists when we're dividing by this, but it's gross and uglier than just doing a long division. There are times when we need a long division. First little question before I give you guys a minute. Who's queen?
X squared.
X squared is my queen this time. Nothing changes except instead of distributing to 2 things, you're distributing thrice. Cool. Need help starting?
I don't know how I'm going to change x squared to 9x.
To what?
To 9x.
So we don't need, remember, what do we multiply this by to get 6x to the 4th? Because that's the very first thing I want to write.
6x squared.
Right, 6x squared right here.
So 6.
That's what I would do, 100%.
What about the next?
So start that, and then once you get this one written, I agree that it's 6x squared. Once you do your distribution here, Addison, if you still have the question, let me know, I'll come look. Cool. And somebody tell me how I knew I needed to start with 6x squared. How do we make this decision? Red, what do you think?
In order to distribute it to the queen to make 6x to the 4th.
Yes, so there's a couple ways to choose first term. First term. There's 2 ways that you can think about this, and I'm okay with both. I know which way I do. I think x squared times question mark equals 6x to the 4th. This is what I do in my head, and I just think it out. If you don't like this process, if we solve for this question mark, you could simply take 6x to the 4th, that first term, and divide it by x squared, and you get the same thing. Like, either way, if we take 6x to the 4th divided by x squared, we do get 6x squared. Okay, once we do this, it's just distribution. 6x squared times x squared is 6x to the 4th. X times 6x squared is a positive 6x cubed. Negative 1 times 6x squared is negative 6x squared. Parentheses and subtract, so we don't get anything goofed up. Okay, 6x to the 4th minus 6x to the 4th, they're gone. How about negative x cubed minus 6x cubed? Negative 7x cubed. And then negative x squared minus a negative, or plus, negative x squared plus 6x squared. Okay, pause. How many terms do we have written here? How many are in our divisor? We need 3. Straight down. If the 9's got an attitude. All right. Now who's queen? It's still x squared. I need to figure out what do I multiply this by to write what number right here. I need a negative 7x cubed. What number is that? Negative 7x. Okay, I'll distribute. We have a negative 7x cubed minus 7x squared plus 7x. Everybody's still on the same page. You guys were bickering a bunch about stuff, and we're about to find where, I think. It's probably right here, right? All right, what's 5x squared minus a negative 7x squared?
12x squared.
It changes to a plus. It's a 12. 9x minus 7x? Positive 2x. And then the last term? Minus 3. Well, Dolan, what do you want to multiply by to give me a 12x squared?
12.
If I do a 12, I get exactly a 12x squared. I don't know why my 2's are different like every other time. 12x squared plus 12x minus 12. There it is again. Weird. Well, what do I get as a remainder? Negative 10x plus 9. Okay. Is the process any different? No, it's a little bit longer. Do you think that I could throw you a problem that's dividing by a quadratic and it has missing powers? Yes. Anytime there's missing powers, what do you have to do? 0. Use a placeholder for it. Okay. Was this a factor? No. If it had been a factor, our remainder would have been 0. All right. We're going to play democracy in here. It's not a game, realistically. Democracy is like a much bigger idea than a game. But we're going to make it a game right now for our purposes. We have two options. We can either have time in class for an assignment, which I'm okay with, if we feel like we need a bunch of practice long dividing. Because I have an assignment that's nothing but long division here. That's first option. Homework with long division. Second one is if you convince me and if you feel like you're okay with long division, knowing that maybe there's a faster way, we could skip this homework for the most part. We could have a couple long division problems on tomorrow's assignment, and we can start looking at what we call synthetic division. Option, so real quickly, we'll take a vote. Option 1 is homework time now with a bunch of long division. Option 2 is we move on to synthetic division. There probably won't be a homework tonight, and then our single homework assignment will have a couple long division instead of pure long division. Are we doing homework in class right now, or are we just moving on? That's the question.
Moving on.
Okay, we'll close eyes and vote real quick. Who wants an assignment that does nothing but long dividing polynomials? Okay, you guys can put your hands down. Overwhelming majority in favor of moving on. We're going to move on. Okay, if you want and need some extra practice long dividing, even though I didn't make an assignment, does your book have a bunch of long division problems? Yes. If you are feeling like you got nothing to do, this is in pink, don't write it down. If you're feeling crazy about it, you can knock out 11 through 21 and you can get 11 wonderful long division problems. Cool. I will probably pick one or two of those to do in the assignment tomorrow. All right, shall we take a quick brain break?
Yes.
All right, so we will see tomorrow when you guys have time to work on stuff. You are going to get a few long division problems. Realistically, the only time that I would ever advise that you use long division in the problems that we're building up to is if you're trying to determine if something quadratic was a factor. Everything else, we should use synthetic division. What does synthetic mean?
Fake.
Fake. It's fake division, which it works. This looks very different than the way that you learned to divide when you did numbers, which is what we just did, the division algorithm. It's a set of steps, whatever. When we look at it, it turns out that there is a better, faster way to do this. So we looked at long division in the first part of 2.3. The second part of 2.3, still continuing on, we're going to focus on synthetic division. Now, this, it is, second half of the same lesson. Synthetic division. Okay, when we're doing this, really, really important. Instead of saying here's a definition of it because we're going to define it with an example that's just not a nice way to define it, here's the most important part. Use when dividing, or when divisor, rather, is linear with a leading coefficient of 1. This is the specific time that you are going to use synthetic division. Has to be linear, which is, can you give me an example of a linear divisor? X plus 3. That's 1x plus 3, but x plus 3 is it. X plus 0 would also count. X minus 5. All of those are linear divisors whose leading coefficient is 1. If it's not 1, we might have to change something. So here we go. We are going to look at there's no nice way to define this, and we're going to do an EG instead of just a formal example. Red.
Just to be clear, the LC means leading coefficient.
LC does mean leading coefficient. Thank you. Leading coefficient. Okay. Now, because this is going to look a little bit different every single time that we do it, we're going to look in general first. So we're going to consider the following. We are going to take a cubic polynomial, which is going to be ugly, but let's say it's ax cubed plus bx squared plus cx plus delta d. That's a cubic, just written with a, b, c, and d as my coefficients. And let's say that we divided this by a linear factor of the form x minus k. Every single time, this x minus k is going to show up. It might look like a plus, but we'll discuss what that looks like. Okay, I wish that we had a good way to show how this actually works, but we don't. Right off the bat, we are going to put just the k term on the outside. Now, if this had been x minus 2, what goes on the outside? A 2. What if it were x plus 1?
1.
Almost.
-1?
negative 1, because it would have been x minus negative 1. Okay, k goes outside. We then have our lovely synthetic box. It's an upside down division. You guys might have had a little tiny bit different notation last year. We'll connect them. If you can show me yours after we do this, we'll make it make sense. Okay, this entire first row right here, because we're going to put 2 rows of numbers here. This first row is just the coefficients, no powers. If we're missing a power, we use 0 as a placeholder. But check it out. We have a, x cubed, right? So just a. And then what was the next coefficient? And the next one? And the last. Now on my synthetic boxes, I also put this, that little vertical bar right here. You'll see why here in a moment. Here's our synthetic division. Now, just to make sure that stuff is clear, and I wish that there was a better way, we're going to say that this is coefficients of dividend. I'm not going to write it here, but I will say it again. If you're missing a power, put a 0. Always use a placeholder, whether it's long division or shorthand. Okay, this is the opposite, and I'm not going to write this one, but it's x minus k from our divisor. To start this, step 1, and I'm going to move it down a little bit. Step 1, drop a straight down. So I don't get goofed up. I always do an arrow here, and I do a. Can anybody recall the next part of this?
You multiply K and A.
We multiply k times a. So 2 is multiply k times a and write below b. So this would be ka in this situation. All right, next, and we're almost done with it, and this is just going to keep going here. We are just going to have a bunch of stuff. We are going to get a new number here, and we're going to say multiply right below b, add b and, or b plus ka. Right below. Now, the steps here, I know they're ugly, but I'm trying to generalize as much as we can. Step 1, we have all this written. Step 2, drop the a, multiply them. Add down, so this would be b plus ka. Like, I'm not going to write b plus ka because it's not going to make anything nicer for us, but that's what's here when we add them down. We then multiply by k again, and do it here, and we just repeat. So we'll do an example of this. Multiply, and do you want me to write k plus ba right here?
Yeah.
It's okay. I don't know that this is going to be super helpful. It'll be really helpful once we actually do the problem. K plus ba, and then
Or
b plus ka, thank you. B plus ka. And then step 3, mult k times b plus ka, and repeat until done. And I'm just going to say repeat, which means we get, I'll wait till everybody's done writing. All right, I'm going to quit doing it, but we would take k times this now, and then if you wanted to, you'd have k times b plus ka, and I'm not going to write it all out because now we would add down again, and then multiply and add down. This box right here, the reason that I do this is my remainder. Every time. Now, I like to draw that vertical bar there to like differentiate it from everything because that is the remainder. Look familiar? Okay, so can you guys see the examples that we did at the start of class? Can you tell me the linear one that we did earlier? And I guess I can probably find it. We did, not B, we did this. I'm going to redo this problem, and we're going to redo this problem. You're not getting any homework tonight, but let's redo this. We know the remainder should be 0. We saw what our quotient should be, and we'll make sense of it. This is our one example in today. So our example is going to be synthetic division. Example, synth for synthetic, div for division. Okay, here it is. Now, looking at this, we have a polynomial divided by something linear. This is of the form, even though it doesn't look like it, this is x minus k. In this particular situation, what value must k have had to turn into a +1 when you do x minus it? So check it out. Right outside of our synthetic box is a -1. Okay, are we missing any powers of x?
Yes.
Yes. So help me with the coefficients. How many x to the fourths? How many x cubes?
0.
How many x squareds?
0.
How many x? How many constant? Almost. -1. Here's our synthetic division. We have 60 seconds to do this big division problem. We're going to finish it. It's going to go quick. First step, what do I do with this number 1? Straight down. It's a 1. Now, I just simply multiply -1 times 1. -1. Now we add them. What's 0 plus -1? Okay, now we just repeat. What's -1 times -1? I draw it on the next one. Add straight down. 1. Okay, -1 times 1. -1. Add straight down. We get a -1. And then one more step. -1 times -1. And our remainder, I think, is 0. At the start of class tomorrow, we'll make sense of what this actually means. Be prepared to jump in right here, right at the start of class tomorrow. Cool, cool, cool. Later, Raiders!